This video is on the product and quotient rules. The product rule is when our original function is y equals ux times vx, so one function with x in it multiplied by another function with x in it. Then the derivative of that using the product rule is u times the derivative of v plus v times the derivative of u. And that's how you see there with the dy and dx's, that's how the formula is given in the IB formula booklet. Now a quotient rule is when our original function is y equals ux over vx, so one function with x divided by another function with x. So our derivative of that is the v function multiplied by the derivative of u minus the u function multiplied by the derivative of v, all divided by v squared. Personally, I find those formulas there in the purple extremely confusing, so how I remember them is just with u dashes and v dashes. So the product rule for me, how I think of it, is y dash equals u dash v plus v dash u, and the quotient rule, y dash equals u dash v minus v dash u all over v squared. Just got a few examples. First one, differentiate y equals x squared ln x. Now with these, for myself, I find the easiest way is to break it up into my u and v. So in this example, u would equal x squared, the first function, v would equal ln x, the second function, and then we do the derivatives of each. U dash would be 2x, v dash would be 1 on x, and then we just apply the rule. So dy over dx would equal u dash v. I'm just going to use the rule as I like to use it. So u dash v, which would be 2x ln x, plus v dash u, so 1 on x multiplied by x squared, and then this would simplify down to 2x ln x plus x. b, f of x equals e to the x multiplied by x squared plus 3 to the power of 4. So the u would be the e to the x, the first part with an x in it, and the v would be x squared plus 3 all to the power of 4. Do the derivative of each part, so u dash would equal e to the power of x. Just the same, v dash, this would be a chain rule, so you need to make sure you know how to apply the chain rule. And the derivative of this would be 8x into the bracket x squared plus 3 all to the power of 3. As I said, that's a chain rule, so make sure you know how to do that. Then from there we can just apply the product rule. So f dash x would equal u dash times v e to the power of x multiplied by x squared plus 3 all to the power of 4 plus v dash u, which would be e to the x multiplied by 8x x squared plus 3 all to the power of 3. Now from there's no reason to simplify with the IB unless it is evident and a simple simplification, then you do not need to do it. So we'll just leave our answer like that. Part C, y equals x squared plus 6x minus 2, all divided by x plus 3 squared. So this one will be a quotient rule. Our u will equal the numerator. U is always the numerator, which is x squared plus 6x minus 2. And then the v is the denominator, which will be x plus 3 all squared. Derivative of these, so u dash would equal 2x plus 6. And v dash, once again, a chain rule, would be 2 times x plus 3 in the brackets. Now apply the quotient rule. So we want u dash v first. So it would be 2x plus 6 multiplied by x plus 3 all squared minus v dash u. So minus 2x plus 3 multiplied by x squared plus 6x minus 2 all divided by v squared, which would be the x plus 3, then the squared there will become to the power of 4. Now with this one, it does look like one you could simplify, so it's one you could go with, but there's a lot of steps there in doing that, so I'm just going to leave my answer like that for now, because it's more the process of applying the quotient rule. Part D, we have f of x equals tan x. Now in this, we just need to also then know our trig identities, and that tan x is the same as sin x over cos x. so it makes it a quotient. And then the u would be sine x, the v would equal cos x, u dash would be cos x, and then v dash would equal negative sine x, and then we can apply the quotient rule, which would be u dash v, so cos x times cos x, which will give us cos squared x, minus sine x times negative sine x, which will end up being a plus sine squared x, all divided by v squared, which would be cos squared x. Now once again, this one we can simplify, and it's recognising that cos squared x plus sine squared x equals 1, the Pythagorean identity. So we can simplify this to 1 over cos squared x. And that is the product and quotient rule.